Kia ora and welcome to the screencast for Workshop 5 for 297101. So today we're looking at joining datasets, small multiple plots, and making tidy data wide. So we're going to use the same data as we used last time, the school role data, but in addition we're going to have a dataset on schools. So we'll start by loading this first code chunk, which will read the data in. Okay, and remember we've got our clean version of the role data, which is going to be what we use, which has that cleaned up level. But we've also got the schools data now, which contains one row per school with a bunch of information. Okay. So the first thing we're going to be looking at is grouping by more than one variable in our chart. So you remember last time we made this chart here, which is the number of students by year level, and it's interesting because you can see what happens as students leave school early. So most students are around till year 11, but the fewer students go on to year 12, and then fewer still onto year 13. And we also have this interesting peak at year 7, which I think correlates, I think is due to students being reclassified, I think, but anyway. But what would be interesting is seeing if there is this distribution that we notice is similar across some of the other variables that we might have, right? So, for example, we've got ethnic group. Do we see the same thing in each ethnic group, for example, or do we see different patterns? That would be of interest, right? So we could try altering the chart for that. So, for example, we could use a further aesthetic for ethnic group. But to do so, the first thing we're going to need to do is get the total number of students by level and ethnic group. Right. So to do that, I'm going to group by more than one variable. So we're going to group by level and ethnic group. Right. Then we'll get the total sum of students. Let's have a look at that. Right. So here we go here. So we've got each year level and then each ethnic group, and we have the total number of students. And then we might throw that into ggplot and then use a further. So let's just do the plot as is. Right. We get the same plot, and that's because the column chart has accumulated the total height of the bars, right? So the bars across the multiple ethnic groups have been stacked. We just can't see them because we're not using the ethnic group to assign anything else. We could perhaps see it if we go make it color equals black and fill equals transparent, for example. Then we can see what's happened is that it's actually it has got the data split into ethnic group, but because we're not using ethnic group as any aesthetic, we can't see which one is which and so on, right? And the default setup for geom_col is to not have a border and have a solid fill color, and of course that means that you can't actually tell that you've got subgroups there. But of course we could color, or perhaps fill, by our ethnic group. Okay, and there we have the chart there. And now, of course, this is hard to see exactly what the distribution is, what the pattern is within each ethnic group because they're stacked. But I think you can get a sense that they're kind of going to be similar, aren't they? I guess we could use position equals dodge to try and get a representation of the actual shape. So there they are, there, for example. Again, it's going to be hard to compare because the total number within each ethnic group is different, right? So it's a little bit hard to figure out whether the trends that we see are similar, but you can kind of get a hint that the trends are somewhat similar, right? You get that same sort of shape in each one. It's just perhaps the amount of drop-off at the end might be different in some subgroups than others. It's kind of hard to tell because of the different heights. Right, so here we produced a chart of the total number of students by year level and ethnic group. But we have this problem with the total number of students being different across the different ethnicities. So an alternate would be to produce separate plots for each ethnic group. right? Because then we can see, you know, they'll have their own axes and we can directly compare them. So for example, we might use code like this, right? So we've got, we take our data and we just filter down to one particular ethnic group and then do a chart, right? So this is going to be a chart for our European students, right, which looks like this, and a chart for our Asian students, which looks like this, which interestingly, there's a difference in shape, right? So this one has this sort of lead up here, whereas this one doesn't have quite so much lead up and has doesn't have as strong a peak. Okay, and perhaps it doesn't have quite as marked fall off at the end as well, right? So perhaps there is some small difference in these two populations. But of course, we'd have to do this like 7 times, right? Write the same code 7 times to get 7 different charts, which is a bit cumbersome. And so ggplot has a way to do this automatically using what's called faceting. So small multiple plots is basically where you divide a data set up by subgroups, and then you plot within each subgroup the same pattern, or the same other variables. So in this case, we're doing our column chart of level by total number of students, but because we've grouped by ethnic group and level, then we've got 7 different ethnic groups, and therefore 7 different values for each level, which we can then use in facet wrap to split the data over 7 different plots. And so we get a chart that looks like this. All right, so this is quite neat because it gives us one chart per ethnic group automatically, which is kind of neat. Now, by default, all the scales are the same, which allows a bit of compression, right? You don't need another axis here and here, so less white space being used up by axis labels and so on, but when they're the same. But of course, in this case, we probably do want to take a hit for that white space and utilize it for axis labels so that we can have different axis labels. Because what's interesting is not the total number necessarily, but rather the distribution within each panel. So let's have a look at the help for facet wrap. So we'll just grab that same code. I guess we just need the ggplot bit, don't we? Because we already have that data set ethnicity by year. Right, and let's look up the help for facet wrap. So I'll put my cursor on facet wrap and press F1. The alternate is to do a question mark and then facet wrap like that. Okay, and run that and that'll bring it up, right? So wrap a 1D ribbon of panels into 2D. Facet wrap wraps a 1D sequence of panels into 2D. This is generally a better use of screen space than facet grid because most displays are roughly rectangular. Right, what does that mean? Facets. A set of variables or expressions quoted by vars, so that's where that vars thing comes in. Right, so whenever you put anything into facet wrap, you put a vars and then the list of variables. It just tells it to look inside the data frame for that we've supplied to ggplot for these variables. Okay, so for ethnic group, for example. And then we notice that there's this argument scales. Should the scales be fixed is the default, or free in one dimension? Okay, so in this case, they're the same. They need to be the same for x, but they don't need to be the same for y. Okay, so in this case, we might want to try scales equals free y in order to have separate scales per subplot. There we go. And so now we can compare the age distribution. And obviously the international fee paying students looks very different because of course most international fee paying students are older, year 11, 12 and 13, or at least are in sort of college, and there's actually not that many in primary school. But we can see some shape differences between these charts, which is interesting. Okay. But we sort of have that general trend of the sort of the fall off in year 11. From year 11 to year 13, but the extent differs, which is an interesting thing to look at. Redo the plot without the international fee-paying students. Okay, so let's redo the same plot. Obviously we just need a filter, don't we, to get rid of the international fee paying students. So we'd grab our ethnicity by year and we'd filter such that the ethnic group is not international fee paying. Right, we'll run that to make sure that we get what we expect. So we've got 90 rows, which will be the 15 levels times 6. That seems right. And then we'd pipe that into ggplot, wouldn't we? Okay, so there we go there. Okay, we could also change the number of rows and columns. So we may want 3 rows instead of 2, for example, right? And it would do it like that. Okay. Or you could have them all in, 6 rows in one panel. It sort of would depend on the dimension of the figure, the final figure that you want to make. Okay, but this allows us to do that summary quite well. So not only have we got the trend in total number of students by year level, but we also have it broken down by ethnic group. So it's an additional aesthetic that we can add to the chart. Okay, so now we're going to have a look at the schools data to familiarise ourselves with that, and then we're going to join this data in with the role data so that we've got per student information with the school characteristics as well. So let's answer some of these questions. How many schools are there in the Palmerston North Territorial Authority? So to answer this, we first need to know which columns to look at, right? So one way to do that would be to schools. We could look at the names function, which will give us our names. Or, of course, we could just click on the schools function, schools data frame, and just have a look through, couldn't we? So what have we got? We've got school, sector, type, authority. No, that's not what we want, is it? School gender, affiliation type, affiliation, a Māori affiliation, regional council. Oh, we're getting close. Territorial authority, there we go there. So presumably, down this territorial authority line, yes, we've got Palmerston North. Right, so we want territorial authority equal to Palmerston North. Okay. So let's answer this. So we want to filter down to territorial authority is Palmerston North. Okay, there we go. So how many schools are there in the Palmerston North Territorial Authority? Well, there they all are. There's 43. Okay, just like that. Now, of the schools in Palmerston North, how many are co-ed, single-sex schools or single-sex boys? Let's have a look. So again, we're looking for, so we're doing our filter, and then we're going to be looking for the right column to use. So we have school gender, that'll be the one to use. Okay, so we're going to do our filter. And then we're going to do a count. So there we go. So there's only one single-sex boys school, one single-sex girls school. That's Palmerston North Boys High and Palmerston North Girls High, and the rest are co-ed. Okay. So alternatively, we could do a group by summarise, right? So we could group by school gender, and then summarise the number of rows, right? Same way that we could do it there. Or I guess because the data isn't actually that big, we could probably just just eyeball it from the filter, couldn't we? If we just have a look through here, if we just go back, go across to the school gender, there it is there. You can see the first 10 rows are all co-ed. Next 10 are all co-ed as well. Then we've got one single-sex boys, one single-sex girls, the rest co-ed. All co-ed. All co-ed, so done, right? Okay. Now, produce a chart that shows the breakdown in secondary schools by school gender of the 3 Takiwa or education regions. Right, so let's have a look and see what our data looks like. So again, we want Takiwa. So if we have a look through, we've got a column for Takiwa. which are 3 main education regions. So we've got Titai Runga, Titai Raro, and Titai Whenua. We want to break down in secondary schools. So how do we get secondary schools? Let's see what else, because we've got primary schools as well, don't we? So how do we get secondary schools? Here we go. Sector equals secondary. That'll do it. So we want to filter down to the secondary schools. Let's check that that works. Yes, we've got fewer schools, 369 secondary schools. And then we want to produce a chart by school gender for each of the takiwa. So we're going to need to do some group by, aren't we? So we're going to group by our takiwa, and then we could summarise or we could count the school gender. So there we go. So here are the different Titai Raro, Runga and Whenua, and there are the co-ed schools and so on, and then there's the count. Right, so once we've got that, we could do our plot. Right, so again, it's going to be a column chart. We're going to use, we might have the school gender perhaps on the x-axis. Our y will be n. Right, and then we want to do something with takiwa. So, for example, we could fill by takiwa. Okay. Or we could, perhaps better might be to facet wrap. Right, so here we see the breakdown in school gender. Now, because of our labels are quite long here, we may want to swap the roles of y and x. There we go, just so that we can get the labels a little bit better. Each of the groups is similar, so the same scale can work for each of them. And notice that there's only a few that have senior co-ed and junior boys. In fact, I think there's only 2 schools, so we might want to filter that out as well. So we'll filter school gender does not equal. And if we have a look through, well, we can just write it out, can't we? Sen.co-ed june.boys. Okay, there we go there. Okay, and actually thinking about this, I think I'm going to re-swap y and x around. I don't think the labels will quite fit still, no. But we could just put these, we could change the orientation so that we just have a number of columns being 1. There, like that, maybe. And then the labels will fit in, and we can kind of compare. Not sure. Anyway, there we go. These bars are very, very wide, aren't they? Which isn't strongly useful, maybe, but feel free to play around a little bit more if you wish. I notice the school gender here is possibly not strongly useful in that most people will recognise what co-ed single-sex boys and single-sex girls means. The N obviously isn't useful here. You'd want number of schools up on that axis, right? So we could perhaps add some labels. Maybe we could get rid of the x-axis and label the y-axis number of secondary schools. All right, something like that, yeah. Here we go. Okay, so now we want to take that schools data and add those columns in as additional columns into our role data. And the common type of join is the left join, where we take the data that we're most interested in, which is the student level information, or the I guess it's the school by year by ethnic group information, and we're going to left join to the schools data set so that we have all of that information as well. And what this is going to do is basically merge the school information based on the school. So you can see the output is it's joined by school. So it's used the common variable school to join by. So you can see that all of these rows with A1 student limited Obviously, we have the data from the roll, which is these first 3 columns after the school. And then we have the data from these other ones, which of course has been replicated for each of those 11 rows, because of course there's only 1 row in the schools data for A1 Student Limited. Now we can use the all data to answer additional questions, right? So, for example, how many students are there in each regional council? So we could take all our data and we could just group by a regional council and then summarise total number of students by just adding them up. Okay, so there we go there. So here's our 19 regional councils, Auckland, Bay of Plenty and so on. Okay, and there's the total number of students. So you can see Auckland, of course, is the biggest, and then followed by Canterbury. Okay, how many students of each ethnicity are there in each takiwa? Right, so again, taking all our data, we're going to have to group by our takiwa and our ethnic group, right, and then summarise the total number of students by again adding them up. Right, so here we go there. So in Te Tairaro and so on, right, you know, we have a number of students of each ethnic group. Te Tauranga and then Te Tai Whenua. Okay. So because all the data is there, we can just use those additional columns. How many students are in schools with a religious affiliation? So let's have a look. So first of all, which column do we need to use? So again, we could look at the schools data because it's going to be a column from there, and we notice we've got affiliation type and we've got affiliation and Māori affiliation. So presumably it's not Māori affiliation, but it might be affiliation type or affiliation. So let's have a look at see what is in these variables. So the common way to do that, so take a look and see what is in the affiliation variable. All right, so we could go all data count affiliation. Okay, so these are Anglican, Baptist. Those are types of church, aren't they? Montessori, I don't believe is a church. That's a school type though. Obviously, we've got Māori trusts. We do have some other churches here, but you know we have some things that perhaps are well, there's some trusts. Most of them though do seem to be school types. Not applicable, obviously. These are probably the ones that aren't religious affiliation, but perhaps the affiliation type might tell us. So there we go, right? We've got no affiliation, which of course is most schools. We've got organisational affiliation, which might be trusts, for example, and then we've got our religious affiliation, which will be all the others, right? So, so now that we know, so we want affiliation type equals religious affiliation, right? So we can do a filter. Right, so that just gets the original, religious affiliation, and then how many students. So we just want to summarise the number of students, don't we? Okay, so we can see that 116,000 students are in schools that have some affiliation with a religion. Okay, you might be interested to see, you know, which religious affiliations are most dominant. Right, so we could take this one step further and we could group by the affiliation and then do our summary, right? And so we can see that, so Anglican 15,000, non-denominational 17,000, so that's not one of these other ones, I guess, but is still sort of a Christian based school is my guess, and the biggest one, of course, is Roman Catholic schools. Okay. And the next one, produce a chart showing the total number of students of each year level within each takiwa using facet wrap to produce side-by-side plots by takiwa. Okay, so total number of students of each year level, so all data, we're going to have to group it by takiwa and year level, right, and then summarize the number of students. Okay, so there we go there, and then we're going to pipe that into ggplot. And again, do a column chart. So X is going to be our level, Y is going to be our total, and then we could facet wrap. Whoops, I want a plus, don't I? Facet wrap by takiwa. Okay, so I've got NA. That's kind of annoying. So a few of the schools, we're not sure of which takiwa that they are in. That might be just because we don't have a match in our school's data directly. Let's see if we can find them. Just as a matter of interest, let's filter where the takiwa is NA. The school is NA as well. Okay. So obviously I've messed up there and have managed to put a bunch of missing data in the data set. This probably happened when I was attempting to clean it. So the original data set that I posted had a bunch of missing data. Had a bunch of character encoding issues in the school column, where some of the macrons were encoded incorrectly. And so some certain computers, so Windows computers with certain environment settings, I think, had issue reading that data in. So as soon as you tried to read the data in, it would fail, right? And you get an error about character encoding. And so I remedied that. I went through and I converted them all to and fixed it all. But obviously what's happened is in the process, perhaps some of the schools were set to NA, and then of course we don't have that. We don't know what schools these are, which is a bit of a bummer. I will attempt to fix that for next time. In the meantime, okay, so in the meantime, we'll redo that chart by filtering out the NAs first. With not NA. Let's try that. There we go. Okay, so here's our side-by-side plots. And again, we could potentially, because there's so many groups, we might sort of do it the other way around, maybe. I think that's quite nice. We can see that the trend is similar across the groups, but the level to which the drop-off happens is perhaps a little bit different. There's less drop-off in this group here at year 12 and year 13 compared to this one and this one. Okay, what about small multiple plots where we have two variables that we wish to facet by? Okay, so we could alter this takiwa plot by also including ethnic group. Okay, by basically removing the international fee paying just to tidy the plot up a bit, and then grouping by takiwa, ethnic group, and level. Right, so we've got those additional pieces of information, and then we could use both takiwa and ethnic group in the facet wrap. So this will put all combinations of takiwa and ethnic group as separate panels. So we're going to get a bunch of them, right? 18 different panels. Now we don't have our NAs here. We've got our NAs. Let's get rid of our NAs as well. Maybe I'll see if I can fix that in the underlying data so that students don't hit the NAs. So here we have our 18 panels, right? Now the problem with this, of course, is that there's a lot of space taken up by the panel name. So the actual panels are very, very small. We also have this white space down here. We could get rid of that by specifying, say, 3 rows and 6 columns, or 6 columns and or 6 rows and 3 columns, so that it's so that the 18 are distributed into a rectangle. But because we've got 2 variables here, it would be nice. So, for example, let's do that. Let's change it to, say, 3 columns. Okay, so now you can see that there's a single column for Te Tai Raro. No, that's unfortunate. The order here has put the ethnic group first, so we actually want 6 columns, don't we? There we go. So the first row there is all Te Tai Raro, the second row is all Te Tai Ronga, and the last row is all Te Tai Whenua. Okay, and then the first column here is all Asian, the second column is all European, and so on. So there's a nice sort of grid nature to this. And because this is a common thing to want to do, there's facet grid for this, right? So let's alter the above, alter that chart and use facet grid instead of facet wrap. And with facet grid, we supply variables for the row and variables for the column. So just switch from facet wrap to facet grid, and then the rows, right, Takiwa, and the columns, ethnic group, and then we don't have to specify the number of columns because it'll be automatic from the variables. Okay, then you can see that this tidies things up somewhat because the row titles can now be taken out to one side. And similarly the column titles. So we've got our panels are much bigger and we get a grid. Now the disadvantage of this plot, of course, is that the scales are vastly different by ethnic group. The scales by Te Tai Raro, Te Tai Ronga and Te Tai Whenua are generally the same in terms of the total number of students, like the height within each of these is roughly the same, but across the columns it's quite different. So we might need to investigate trying to normalize that in some way. So you can see here, play around with which variable is in the rows and which is in the column, and the scales parameter to produce something that shows all subgroups reasonably well. So let's have a go. So one thing we might want to do is just swap the order of the rows and the columns. So let's put the ethnic groups in the rows and the Takiwa in the columns. See what happens when we do that. Okay, so that's fine. The advantage potentially of doing this is that now it's much easier to change these, the y-axis. So the x-axis is being fixed as fine, isn't it? Because they all sort of cover all year levels, but the y-axis is the problem. But now that we've reorientated it this way, by changing the scales on each of these rows, we will basically boost these up, right? So let's investigate the scales parameter there. It's going to work the same way, right? So we want a free y-axis, okay, and that boosts things quite nicely. All right, so now we can see all subgroups relatively well. We can immediately see that there's a difference, particularly in Pacific students and in Asian students, in that Te Tai Raro, which is the top of the North Island, has a much higher population of Asian students and Pacific students compared to the other groups. Whereas Te Tai Ronga, which I think is the South Island, I'm not 100% sure, has a higher numbers of European students, for example. Let's see if we can do that same thing if we swapped the rows and columns around. So let's go see what happens when we do it this way around. Okay, then you can see that scales equals 3y doesn't actually help us much here because the scale is constant for in the grid, right? So it has changed the scale, so you can see that this one in the middle goes up to 15,000, but they're constant across the row because, of course, because of the way that we've the grid has fixed the axes only on the bottom and the side. Right, it's not like facet wrap where you get axes for each individual item. We don't have that here, so we therefore it's going to make sense to have it round the other way because that's where the scale differs. Okay, so let's go back to that one there. That's the better plot because it allows us to see those subgroups in good numbers. So the last thing that we're going to look at today is pivoting wider to create tables, or to turn tidy data into wide data. So up till now the data we've been playing with is tidy in that each row consists of a single observation and each column is a separate variable. Okay, so in this column, in this example here, in our role data, right, we've got variables of school, ethnic group, level, and students, and then each row is an observation of those 4 variables, right? It's the combination, it's the number of students per breakdown of those other variables. And that enables us to do all of the work that we've been able to do in dplyr because of the tidiness. And the same with the charting, right? It's because of the tidiness that it allows us to do that. For example, if we had separate columns counting each ethnic group, right? So we could represent the same data by having A1 student limited and then the year level, and then we could have number of European students, number of Asian students, number of MELA students, number of Pacific students, and so on as separate columns. That would give us the exact same data. It's just now it's hard to do summaries, right? Because it's hard to summarize by ethnic group because we have to summarize each of those 6 ethnic groups separately, right? We can't just group by ethnic group and do the work. We have to do it separately. Similarly for charting, if we want to put all ethnic groups on a chart, we need to say, we need the number of students on the y-axis, for example. But now we've got 6 columns with the number of students, 1 for each ethnicity. So we can't do it, right? So that's the advantage of tidy data. Now the disadvantage is that sometimes we want things to be in a different form, right? So let's have a look at this, for example. Let's have a look at our ethnicity by each takiwa. Right, so this is the number of students by takiwa. So we've only got 27 rows now. So this is a much smaller data summary, right? But it's kind of hard to read, right? Because if we want to, for humans to eyeball it, right, it's kind of a useless table because while it contains everything we need, it's hard for us to compare. So for example, in order to compare within ethnic group, so if we look at the Asian group, for example, we can see that there's 84,000 in Te Tairaro, but then we have to go down to the next Asian entry and sort of go across to find which takiwa that group is in, and so on, right? So it's hard to compare because the student numbers is all down a single column. It would be much easier if we had a separate row for each ethnic group and then separate columns for each takiwa, right? So you could just imagine this, instead of just having a students column and a takiwa column, you could have a Te Tairaro column, a Te Tairunga column, and a Te Taiwhenua column, and then the number of students in each one. And that would give us a 2-dimensional table, which is nice and readable. Okay, and we can do that by using pivot wider from the tidyr package. And it works like this. You take your data set, which we've saved there, into ethnicity by takiwa, and we pipe it into pivot wider, and we need to specify which column is going to be used for the new column name. So in this case, we want to take the students column, and we want to create new columns for each takiwa. So our column names are coming from our takiwa column, and the values that are going to fill those columns are coming from our students column. Right, so that's what we specify. Our names are from the takiwa column, and our values are from the students column. When we run that, we get a table that looks a bit more concise. Right, we still have the silly NA, but that's okay. You can kind of ignore it if you like for now. I will try and fix that later. But now we can easily compare across the row, right, which is within ethnic group, and we can also compare down the columns, which is between ethnic group. Right, so this is a much more usable summary for human readers. So let's have a go. Create a table with the total number of students in each year level by takiwa. Right, so this is similar to the above, right? So we're going to take out all our data, and we're going to group by takiwa and year level, and then we're going to summarize for the number of students. Right, so here's our data. But now we're going to take our total number of students and distribute it across our takiwa columns, right? So we're going to pivot wider. Our names are going to come from our takiwa column, and our values for those columns are going to come from our total column, right? Name of the column. Right, and here's our nice little chart. Okay. And again, we can compare across the rows to see the difference in numbers within each year level. So you can see that there are differences. So Te Tai Raro seems to be the biggest in the early years at least. In fact, it's the biggest across the board by the look of it. Te Tai Whenua has much lower numbers in year 13 by the look of it than the others, and so on, right? Create a table with the number of each ethnic group in each year level. Okay, so again, same thing, right? Take our data, do our data manipulation. So we're going to group by ethnic group and year level. We're going to summarize it up to get the total number of students. Right, and then we're going to pivot wider. So you need to choose what you're going to pivot. So you could pivot, you could take the name from the levels, or you could take the name from the ethnic group. Let's try both. Right, so let's go from the level. Our values either way are going to come from our total column. Right, so that gives us columns for each year level. Okay, and rows for each ethnic group. And we could also do it around the other way, right? So we could go by ethnic group instead. Okay. Again, it allows us to compare across the row and down the column in a sensible way. So let's try adding a total column to this, to the ethnic group by takiwa column. So let's go back to our ethnic group by takiwa column. That's this one here, table rather. So our table from before. So here it is here. So what we want to do is add another column out here for the total. So the trick here is just the keyword by ethnic group rather. Let's do that. So the trick here is that we want to, so there's a couple of ways we could do it, right? We could just add these up. That's going to be a little bit complicated, but we could do it, right? We could just go mutate total, so method 1, add them up, add the columns up. So total equals, so we could take Te Tai Raro plus Te Tai Runga plus Te Tai. Let's ignore the NAs. Right, that's one way to do it. So now we've got our total column there. Okay. So that's one way to do it. Problem, lots of typing. And it's then not easily generalized, right? If the Ministry of Education decided to split these further into, say, 4 different ones. So Te Tairunga Raro is Auckland and above, I think, and Auckland tends to grow faster than the rest of the country. So perhaps at some point they might split that into 2. Then we would have to update our code, right? Because we are relying on the actual names in our sum. So another method. Do the summation, or do the total before pivoting, right? And the idea here is that before pivoting, we kind of want the group the other way around, I think. Let's have a look. So let's do our summary. Got to think a little bit in advance, right? So here's the data, and it's currently grouped by takiwa. So we'd have to regroup it because we want our summary to be by ethnic group, don't we? Our total column, because our ethnic group is going to be in the rows. So we want to group by ethnic group, and then now that we're grouped by ethnic group, we can just add them up, right? So we're gonna we still want the total column, but we just want an additional piece of information for a grand total, which will be the sum of the total number of students. All right, so what I've done here is for each ethnic group, I've added up the total information. Right, so I've taken 84,323, 34,353, and so on, and added them up. So you can see that it's repeated, right? Because there's multiple rows for Asian. But now when I pivot wider, so right, we're going to again just go from our total column. I don't need it in quotes, do I? Because these are things that are already in my data frame. You can see that I still have my grand total, and I have my ethnic group, and now I have my columns. Okay, the only issue here is that the grand total, if you like, is sort of in the wrong spot, isn't it? So we could use so there's a handy function for that called relocate. So our grand total equals, we're going to relocate our grand total column after equals last column. You can look up the help for relocate if you're interested in how I knew that. Okay, so here's our grand total column. This of course includes the NA. And the nice thing here with this code is this code doesn't depend on the values that takiwa or ethnic group takes. Right, so if we add an extra ethnic group in, it's still going to work. If we add an extra takiwa in, it's still going to work. If we remove a takiwa, like we get rid of those NAs, it's still going to work, right? Still works. Okay, so that's the power of working with tidy data. Now this is a little bit, I could reduce this code a little bit by just changing the order of this group by here. Right, so if I grouped by ethnic group and takiwa, ethnic group then takiwa, the total will be within ethnic group and takiwa, which is what I want, but then it would automatically remove the grouping by takiwa and leave me grouping by ethnic group, so I could get rid of the line, this additional group by line. Okay. Okay. All right, let's have a look at, there's actually another way, now that I think of it. So method the third, use a package. Okay, so the janitor package, I think that's what it's called, has adorn totals or similar. All right, so let's do the same thing. Let's generate our group, our table. Right, so there's our table. Now we want to adorn this table. Oh, there we go. Add totals column. This function is deprecated. Use adorn totals instead. Adorn totals. Okay, where equals row. There we go. Name equals total. There we go. Automatically done it. Now it's output something that's a little bit of a different format, in that it hasn't automatically done it with a data with this data output. But nonetheless, we've got the exact same information. Oh no, we've got a total row here. We don't want a total row. We want a total column, don't we? Hang on a sec. So where equals column. There we go. So there's our total row. Okay. If we wanted to print it up, we could make it a cable. Right, and so there's a pretty table there. The same information. Okay, so this adds the total row for us automatically. Obviously, there's a bunch of assumptions here in that you know, you're kind of assuming that you're supposed to add up all the numbers in each row. Okay, we don't have that problem when we write the code ourselves. If there are additional rows that have numbers in them that we don't want to add up, we could have taken care of that. Okay. So let's have a look at this last one. Try creating a table with the percentage of students of each ethnic group within each takiwa. Right, so this is similar, right? So we've got all our data. We're going to group it by, let's do ethnic group and then takiwa. And then summarize students equals sum of students. All right, so this is the number of students. Let's get rid of the NAs. Right, so that's the number of students. Now we want a table with the percentage of students by each ethnic group. Within each takiwa. Okay, we're going to need it the other way. We're going to need the group the other way around, aren't we? Okay, so there's our grouping information. So the reason I've grouped it this way around is that we want the percentage of students of each ethnic group within each takiwa. So at this point, you can see that I'm still grouped by takiwa. So now any computation that I do is done by within takiwa. So what I want to do is I want to work out the total number of students in each takiwa and then divide students by it, right? So I'm going to mutate the proportion is students divided by the sum of the students, right? So that sum is being done within each group. Students is of course just the value from the row, and so we get the proportion. And now we want the percentage, so let's multiply by 100 to get percentage. So there it is there. Okay, we could call it percentage now, couldn't we, instead of proportion? Okay. You can see that they add up to 100 within each takiwa. And so now we want to produce a table, so now we can do our pivoting. So we're going to take our names from our takiwa, and our values are going to come from our percentage column. And so we see well, we haven't quite got what we want, have we? So this is looking pretty good at the start here, all right? But then the next 7 entries are for Te Tai Runga. And then the next 7 entries after that are for Te Tai Whenua. Okay, so it hasn't done the compression thing, right? It hasn't paired up the 3 rows with each other. And the reason, of course, is that the students column is still there, and they aren't the same value. So we want this top column here to match up with this one, right? But because the students' entries isn't the same, it can't drop it down to 1. So we need to get rid of our students column first. Right, so we could select out our students column. And now it's in the form that we want. Obviously, these are, perhaps we might want to round these. There's a couple of ways you could do that. You could utilize the knitr cable package, cable function, which has a digits function, right? So that automatically rounds it within the table. The alternate is that you could also just do that back here, right? So here's our percentage, we could round that. Okay. So lots of ways to achieve the same thing. I'll see if I can fix up that NA for you, because that's kind of annoying. We'll end by knitting our document just to make sure there's no errors. And that looks good.